Okay, so the last part I'm going to talk about is what do we do about it, the art of seismic self-defense. And I'm going to talk about 4 defenses. So one is get ahead of it, another is contextualize, which is sort of a polite term for point the finger. The third is, of course, a good offense is the best defense. And the fourth is get creative, because there's a lot of places water can go. So I'll move through these pretty quick. So defense number 1 is get ahead of it. So look at the situation that I've got on the map right now. Here's a disposal well in New Mexico that's had one 2.9 magnitude quake within 10 miles, but not a second one. If you own that disposal, you better be on high alert for a second quake happening in your area that's 2.5 or greater, because you have to report in to the OCD within 24 hours of that happening, right? And you can see you're in a pretty risky spot there because you're sitting right on a fault line that looks pretty similar to where that last quake happened. And if it does happen, then you fall into one of those red circles there where you've got, where you've got all kinds of restrictions coming down. So you've got this 24-hour response required, which is pretty tough, or it's next business day. And so what can you do? Well, in our system, you're able to set up automated alerts for any geo area on the map or any set of geo areas and get alerted for all kinds of things. One of which is if a seismic event happens, you'll get that alert same day by an email and you can take your action. But actually there's some other cool stuff you can alert for, right? You can alert for frac crew movements. So if a frac crew enters any area, any lease area that you've mapped because you want to stay away from frac hits on your leases, or because you're a mineral owner who wants to know that you're going to be owed some royalties soon and there's a frac crew that moved on to your minerals, you can automate that alert. You can automate the creation of frac ponds and mud pits because those tell us that a completion crew or a rig is coming. You can automate for the rig movements because we've got those. You can detect new well pads and get alerted for new well pads because it turns out that well pad construction is much more predictive of drilling than drilling permits are, because it turns out a drilling permit costs $250, but a well pad costs $250,000. So when you see the well pad get built, you know they're actually going to drill the well. It turns out that that correlates 90% to new drilling in about 60 days, whereas the drilling permits only correlate about 19%. In other words, drilling permits are essentially random with respect to drilling. But if someone builds a pad, they're serious. So that's a good thing to alert for. So another way of getting ahead, of course, is take a look at where you're going before you spend $5 or $10 or $20 million drilling a disposal there, right? So don't buy or build or try to avoid sending water into saltwater disposals that are really, really near faults or big quakes. And I know that sounds pretty obvious, and in a lot of cases, well, too late. But you know what? We see plenty of examples in our system where somebody could have avoided that and didn't. So here's one in the NCR district. And if you get this presentation later, it's a pretty small text there, but you'll see who it is. And there was a 4.0 magnitude quake less than 2 miles away. And they're in the middle of about a dozen fault lines, some of which clearly relate to where that quake happened. And they permitted that disposal and started pumping water into it after that 4.0 quake happened on what looks like the same fault line less than 2 miles away. What you also see on that chart is you see the injection volumes and pressure utilization for that well. And on the left side, that's on the right side, on the left side you see when quakes started happening. Right after they start pumping water down that hole, they have 26 more earthquakes in less than 1 mile of that well that didn't happen until they started pumping water down that new well. So those are things you probably want to get ahead of before you invest that money, because that's a pretty tough association to get out of. Another way to get ahead is to make sure, especially if you're an operator, check all your producing leases. Make sure that you know whether they are sending any water today into SRA wells, because a lot of times that is not so clear. And that way you can plan ahead. And on this map, what you're seeing, those purple dots, are producing leases that have sent at least a little bit of water into an SRA well in the last few years. And some of those producing leases are pretty far afield from the SRAs. In a lot of cases, those operators probably don't realize that that water is going down a pipeline quite a few miles to a big disposal that happens to be in the middle of an SRA. So you really need to understand where your assets are sending water, because one thing we know about environmental law is that liability is traced to the wastewater generator. That's just an EPA thing. So if you're an operator, you want to know where your water's going, because at the end of the day, if there are problems, someone is going to come looking for you. You're not going to be able to just cut that off at, the poor guy who was running the disposal well that it was initially traced to. So as an operator, you've got to take responsibility for where your water's going, even if your MSA says that that liability ends at the edge of your lease. You need to know where your water's going. It's also a supply chain issue, right? Which is, forget about the liability. You need to make sure that you're ready and have your contingency plans. If you're sending water to a disposal that's either sitting on a fault line or where there's been a lot of quakes happening or it's already been cut back on an SRA, you need to be ready for where you're going to send it next. Maybe you want to start working on those rights of way for your alternative pipeline, because water pipeline rights of way are really hard to get. They're actually much harder than gas and oil rights of way. And so you need to be working ahead of time to make sure that you're building out your alternatives if you're currently exposed very heavily to kind of a sole source situation where your water, the only economic way to get rid of your water is put in a pipe that's going to a disposal that's either in an SRA or looks like, looks like could soon be subject to some kind of restriction based on where the fault lines are and where the seismic activity is going. So one of the things we do is we actually map out those flows of water. So you can see in this case, here's an operator that's pretty far away from that SRA, but is sending a significant amount of water into a disposal that's in the middle of the Gardendale SRA. And that would not be obvious if you're that operator. But there's a lot of other opportunities at commercial disposals that are near there that aren't in the SRA where you might want to plan ahead and take advantage of that before those get filled up by others getting ahead of you. So the second defense I'll talk about is contextualized. I said before my original term for this was point the finger. But the key point is everything is in context. And when these seismic events happen, there are all kinds of different potential contributing factors. It's really, really hard to know exactly where they came from, and they might not have exactly come from any one place. But consider this example that's up on the chart right now that's in the NCR SRA. This is a great example. So down at the south end of that chart, you've got an SWD that got a 60% reduction in capacity off of the SRA. Now, there's no fault lines that we know of that are right near. That doesn't mean there aren't any, but there's nothing public about any fault lines near that disposal. There weren't any other earthquakes near that disposal, but there was this one that was about 2.5 miles north that I've got marked there, that 3.0 magnitude earthquake that's right up there where those two fault lines crisscross. But there's no clear connection from that to that disposal down at the bottom there. Why did they get that 60% reduction? By the way, you can also see if you look at the injection on that disposal, it had almost no water going into it. It was like at 5% pressure utilization, 5% volume utilization. The disposal was active, but it was barely being used when that earthquake happened. Well, what was going on up closer to where that earthquake happened? Well, first you've got those two fault lines that crisscross right there. You've got a pretty big production well sitting right on top of that crisscross where that quake happened. And we know one of the causes of earthquakes is depletion. Right? It's production of oil and gas and water comes out of the ground and makes some empty zones, and sometimes things collapse. But also, one of those fault lines runs right to a frac that was happening during the 2 weeks that ended the day before the earthquake happened. And in fact, there were 6 different fracs that happened less than a mile from that quake in the 6 to 8 weeks before the quake happened. Now, we don't know whether those fracs caused that quake. They might have nothing to do with it at all, although this one is sitting right on top of that same fault line, like a mile away. But if I own that SWD that's 2 miles to the south that got the 60% reduction, I would probably want to know that stuff and be able to point it out when I argue to the Railroad Commission, I shouldn't be getting blamed for this and I shouldn't be getting cut back 60%. This makes sense in no way, right? You're welcome, EOG, if you're out there. So these are kinds of ways that contextualizing can make a big difference in defending your assets. You have to know what's going on everywhere else, not just at your own assets. So there's all kinds of things you need to know going on, right? You need to see where the fracs are that day. Remember we talked about earlier, frac focus reports sometimes a year late, if never. You will never know where the fracs were to defend your disposal assets unless you have near daily reporting of where the fracs are. If you wait a year for the frac focus intel to come out, which it might never, you're not going to be able to defend yourself. You need to know where the injection is happening, where the production is happening, and you know where the faults are that everyone else is near, right? You've got to be able to paint that big picture when you go in to defend your asset from restriction that should not have been put on you. You can also look at the pressure and volume trends of other disposals near your events. Now, this is in the same NCR area. Again, I mentioned this is an operator who we've never met them, but here's an unfortunately kind of sadly clear case where right after this disposal started pumping a ton of water into it and really pushing pressure utilization levels up to like 70-80%, which is what you're seeing on that graph right there. Right after that happened, a whole bunch of quakes happened within like 1/10 of a mile of the location of that disposal. And there's nothing else right there. Again, if I have that EOG disposal that's like a few miles south of there, I'd want to know that, right? Look, there's other people who are jacking it up, pumping a lot of water in, looks like they're causing quakes, but I'm not, right? So you need to know what everyone else is doing to defend your asset. Defense number 3, everybody knows the best defense is a good offense, right? So there's a lot of opportunities created by these SRAs, especially if you're in the commercial midstream or commercial disposal, logistics, or recycling businesses. You can win water from SRA disruptions. You can spot water recycling deals happening near you because everybody wants to recycle more water now, but you need to know where that is. And you can also get in and predict where operators are going with the kind of intelligence that we provide. So here's a good example of this where there's an XTO lease right on the edge of the Gardendale SRA. They've been sending a lot of water into a commercial disposal that's right in the middle of the SRA that's now got a shut-in order. But there's another commercial disposal that's actually only about 1/3 of the distance from the one they're using now that's outside the SRA. If you own that commercial disposal, in this case, you're welcome EDS, you'd want to go to XTO and say, hey, I've got a better alternative for you than where you're sending that water right now. I have your answer. And by the way, it's only 2 miles away, right? So there are opportunities to grab here if you're paying attention to where everybody is sending their water and where your competitors are getting their water from, especially if they've been disrupted. Another one, which I talked about a bit earlier that I love, is spotting recycling deals, right? The biggest problem with recycling today isn't water quality, it's timing, right? Every recycling deal is a problem of both time and space. You need to have the ability to move that water between locations by some type of pipeline, because if it's going in truck, the numbers aren't going to work. And the times need to line up. You need to have somebody who's starting up their frac program, who's going to need a lot of recycling water coming in to replace fresh water and brackish water. And you need somebody who's getting toward the end of their frac program nearby, near a pipeline, who's going to be able to send you water and get paid to sell you recycled water instead of them paying to dispose of it. The only way to know that is to know where the frac crews are right now, every day, and everyone that they're working for, and know where they are in relation to all of the commercial pipeline and operator pipeline infrastructure to know which dots can be connected on the map, not just in space, but in time. Another way to mount a good offense is to go in to win with operator demand. So what you can do in the example I'm showing here, it happens to be Mewbourne, but we're able to show you where every well pad has been built, every well pad that has a permit, which means they're imminently going to be drilled. And we're able to show you where the real ducks are today, because we know which wells have been spudded, because we know where the rigs have been, and we know where the frac crews have been. And so we know exactly where the live ducks are right now, which operators they belong to, and which ones have frac crews working for that operator near those ducts, where it's pretty obvious where they're going to go from there. And you see the pipeline infrastructure, you see where the frac ponds are, you know what kind of water needs they're going to have, and at that point you can walk in with a fully baked plan and be able to say to that operator, here's how I'm going to save you money, because I see where your ducts are, I see where you're fracking, I know the timing of when you're going to need water, and here's what I'm able to deliver to you from our infrastructure or from our recycling program, right? So you go in looking smart and giving them the gift-wrapped solution rather than just trying to get that meeting with them, so because they feel like they're going to waste their time telling you what they need. You need to go in already knowing what they need, right? Because they don't want to just spend lunch with you telling you about their whole program. And the last I'll mention, your defense 4, get creative. So one key point that we've noticed is the Permian Basin actually has 47 different formations that can take water. Only about 4 of those really ever get used, right? Over the Midland, you got the San Andres, shallow, and the Ellenberger deep. Over in the Delaware, you've got the Delaware Mountain Group, shallow, the Devonian deep. There's a lot of layers in between there, and a lot of them have a lot of capacity. Now, there's some complicated geophysical issues there. It's not always suitable. It depends on, kind of permeability and porosity and where the fault lines are and a bunch of other things. But the key point is, overall, there is plenty of room to put water in the subsurface in the Permian Basin. But today, more than ever before, it really matters that you're smart and strategic about where you plan to put that water. We're no longer in kind of the wildcatter phase of the saltwater disposal business, where if you can get a lease, you poke a hole and you put the water down there until it stops, right? And that is how it was until like a couple of years ago, right? Now you actually have to do the geology and the geophysics and figure out where everything is and make a smart decision where to put that asset, because you don't want it to get shut down a month later and write it off. So there's a lot of smart work to be done and where to put the water in the ground. There's plenty of room to do it, but now we really have to be smart and strategic about it. You can't just poke a hole and expect it to work. And so with that, that's the presentation there. We talked about the seismic response areas. We talked about the specific commercial impacts of those SRAs. And we talked about the art of seismic self-defense, getting ahead of it, contextualizing, having a good offense, and getting creative. And with that, I welcome your questions, if there's any time for any of those. And of course, we'll be here tonight and all day tomorrow. Stop by our big Sourcenergy booth next door. We'd love to show you what we're doing.